In this lesson, you will investigate relationships between quantities by using points on a scatter plot, and we'll also be able to use lines of fit to make and evaluate predictions on a scatter plot. So here are our vocabulary. A scatter plot is two sets of data plotted as ordered pairs on a coordinate plane. A positive correlation is in a scatter plot, x increases while y increases. So it's a lot like slope. It's going to go uphill from left to right, just like a positive slope would. A negative correlation is in a scatter plot as x increases, y decreases. So it looks like a negative slope. If you read it from left to right, it's going downhill. A line of fit is a line that describes the trend of data in a scatter plot. We're basically going to pick 2 points, connect them to create a line. Bivariate data is data with 2 variables, and all scatter plots are bivariate data, where you're looking for some kind of relationship between 2 items. And then linear interpolation is the use of a linear equation to predict values that are inside of the data range. And we've talked about extrapolation, where you're predicting data outside of the data range, and so we'll use both of those today. So the first thing you're going to look at is scatter plots themselves. So here are some examples. This is a scatter plot that has a positive correlation. As you can see, it's going uphill. This is a scatter plot that has a negative correlation. As you can see, it's going downhill. And this is a scatter plot where we would say it has no correlation. It doesn't look like it's going uphill or downhill. So if you would look at this scatter plot, what you will do in your assignment is you will look at a scatter plot and determine if it has a correlation. So looking here, I would say that yes, this is going uphill. So I would call this a positive correlation. Now, you're also going to have to explain it. So here's what I'm going to ask you to do. I want you to tell me exactly what's going on if you look at the labels. So here, as the hours increase, the amount of money paid also increases. So something about how the longer you work, the more money you make. Or the longer you work, the more wages you get. Something like that. And you will have to write that in a sentence. So I'm going to say, as the hours increase, the wages increase. So the only time you would not, on your assignment, have to describe is if it's a no correlation. So you try the example in your notes. The next thing that we're going to look at is when you're given a set of data, can you make a scatter plot of it? So I'm going to go ahead and just do a rough scatter plot here, but I'll give you a chance that you could do a nice one in your notes. So in the year 2000, I'm going to make this 2000 here, and then this would be 01, 02, and so on. And then you have to determine what you want your y-axis to be. Since this is 13,000, I obviously don't want to count by ones. So maybe you want to count by 5,000 or something like that. So here's 5,000, here's 10,000, here's 15,000 here. And you would basically just plot each point. So you're going to put 13,000 here, about 12,900 there, 12,000, 11, 11, 10, so on and so forth. What you would see then is what kind of correlation is going on here. And if you would look at these numbers, this is more proof. It is a negative correlation. So we would say it is a negative correlation, and what would our description be? Well, our description would be as the time goes on, as years go by, fewer CDs are being sold because the sales are CD sales. I should have said that. Sorry about that. So the number of CDs being sold goes down as time goes on. And that makes sense in our world today because most people are using streaming for their music rather than actually purchasing CDs. So you're going to make your own scatter plot in your notes and then describe what's going on with it. So go ahead and try that now. Now, the last thing that you're going to do is use either interpolation or extrapolation. You have plotted all your points on a scatter plot. You have looked to see what the correlation is. Now we're going to actually use what's there to do a little algebra and figure out what's going on, in this case, in the year 2008. Well, look here. I do not have 2008. So 2008 is what we call extrapolation because I'm looking for a year outside of the data. If I were looking for a year inside of the data, like 2002, then that would be interpolation because it's inside the set of data. So since we're looking for 2008, what we have to do is we have to figure out what's going on here. We know it's going to be going down, so we need to have some specifics. So I'm going to pick this point here and this point here. What I have are two coordinates, so we're going to do y2 minus y1 over x2 minus x1. And as you type that in on your calculator, you're going to be able to see that, yes, this will definitely be a negative slope. So I get negative 1676 over 2. So I get negative 838. Now to get your equation of that line, you can use point and a slope and use point slope formula. You could plug in values and solve for b and find b because you've done both. I'm going to go ahead and use slope formula. So I'm going to say y minus 11233 equals negative 838 parenthesis x minus 2003. We're going to go ahead and solve like we did in the last couple lessons. So I'm going to distribute first. This is a plus. I'm going to take 2003 times 838. Now we're going to add this 11,233. And we get y equals negative 838x plus 1689747. So if you wanted to know what was going on in the year 2008, you would plug that in here, negative 838 times 2008. We'll go ahead and do that. And then we're going to add $1,689,747. So we get about 7,043. So in the year 2008, about 7,043 CD sales existed, and that makes sense because it's going to be going downhill. So that is called extrapolation when it's outside the data. So you try the one in your notes.